All right, 4.1, relations and functions. So starting with chapter 4, basically we're doing a lot of stuff with relations, functions, domain, and range. So that's what today is all about, is a lot of definitions. So starting with relation, our definition for a relation is basically just a set of ordered pairs. An example of this would just be curly brace, the set of 2, 3, 4, 5, and 6, 10. So just ordered pairs, like if you would see them on a graph, this would be on the XY, 2, 3, 4, 5, 6, 10. So we could have a set here of ordered pairs. Some characteristics, just like the definition says, we could have ordered pairs. These ordered pairs are always listed as X, Y. We could see them written as a table, given all of your X and Y values in that table. We could see them as a mapping. So having these little circles here, mapping our X values to our Y values, however they're mapped out. The last one we could see is a graph. Given our x-axis and our y-axis, like our example of these ordered pairs, these points would be graphed on the actual graph. A non-example of a relation would be something like, given some ordered pairs of 2, 3, 4, 5, and a single term 7. This would not be a relation because we have here some ordered pairs that could be listed off as our table, our mapping, and our graph, but 7 would not be mapped to anything. So that would kind of be like a non-example of a relation. All right, our next definition is a function. A function is a relation. So if it is a function, we already know it's a relation. And this relation consists of 3 different constraints. We have a set called the domain, containing numbers called inputs, which all of these inputs in our domain come from the X values. The next, they also have a set called the range. These contain numbers called outputs, which consist of our Y values. Now, in order to be a function, these pairing of your inputs and outputs, or your X values and Y values, this pairing is such that an input is paired with exactly one output. That's going to come in really handy for our function definition. We can only have inputs and outputs, so that each input is paired with exactly one output. The input variable is also called an independent variable. And the output variable is called the dependent variable. Because its value depends on the value of the input variable. So this output here depends on what that input was. And the last thing we're going to do definition-wise is a roster notation. We've already done a couple different notations. We just came off the chapter with interval. So this new one is called roster notation. This will be used to represent our domain and range of listed items. And we always list those items from least to greatest. All right, so enough definitions. A lot of this stuff is going to sink in while we go through the lesson. So the first thing we're going to do is we're going to talk about two different relations. We know the relations because I'm going to give you a set of ordered pairs, and we're going to express them different ways. The first set of ordered pairs, a set is always listed off with your curly brace, and then listing the ordered pairs. The first one is -2, 3. 0, 5, 4, -1, 5, 2, and 5, 3. All right, the next thing we're going to do with this set of ordered pairs is we're going to list them off as a table, our x and our y values. Notice, like I said before, these are always x and y as your ordered pairs if you want to go ahead and label that. X and y if you've forgotten from past years. So I'm going to list these off as -2, 3, 0, 5, 4, -1, 5, 2, and 5, 3. Our mapping for this is we're going to list off as -2 will map out to +3, 0 maps out to +5, 4 maps out to -1, 5 maps out to 2, and 5 also maps out to the number 3. Our graph for this, we are just going to graph these ordered pairs. Remember, these are your x values, these are your y values. You've got positive and negative for x, positive and negative for y. So the first order pair is -2, 3. So x always comes first. We start at the origin and go -2, +3. The next order pair we have 0, +5, so nothing on the x, but +5 for the y. The next one we have 4, -1, so we have +4 and -1. Then we have +5, +2, and +5, +3. All right, so this is a relation because this consisted of all ordered pairs that we could express as a table, a mapping, and a graph. The last thing we're going to do is we're going to list off the domain and range for these. So if you want to go back to that definition there, your domain are all of your inputs or your x values. And we're going to list these domain and ranges in our roster notation from least to greatest. So for this first one, I'm going to start with a curly brace because that's how roster notation starts as well. And I'm going to look at all of my x values because my x values list off the domain. In order from least to greatest, which these are already listed off, I'm going to put -2, 0, 4, and 5. You do not have to list 5 twice because 5 is already listed in the domain. It tells you what values are your inputs. So these are just your x values or your inputs. Now the next thing we're going to list off is the range. The range are your y values or your outputs. So here you have listed in your table your range. So starting with your curly brace. Now, these are not listed in order right now, so what we're going to do when we list them is we are going to put them in order, starting with this -1. Then we have 2, 3, and 5. Just picking off our y values, putting them in order. We do not have to list 3 twice, and then finishing off the curly brace. These are our y values or our outputs. Now, one thing I want you to notice before we move on to our next set of a relation is we're going to talk about what it means to be a function. So let's go back to our definition of a function. We have a set called the domain, or the inputs, and we exactly have our set right here listed off. We have our set called the range, or the outputs, and that one is also listed off. And our last constraint to be a function, a pairing of inputs and outputs such that each input is paired with exactly one output. So your inputs can only be paired with one output. Let's take a look at this. Looking at our ordered pairs table, mapping, and graph, we notice that the input 5, it has an output of 2, and the input 5 has an output of 3. We can see here also in our table, 5 is mapped to 2 and 5 is mapped to 3, as well as our actual mapping. So this here is not an example of a function. So I'm going to put to the side here, not a function. This is not a function because it has 5 with different outputs. It has 5 with an output of 2 and 5 with an output of 3. You can see this easily in a table and a mapping. The best way to see it on the graph, we call it the vertical line test. If you can take a vertical line and pass it through all of the points on your graph, and it does not hit more than one point at a time, then it passes. But if it does hit more than one point at a time, it fails the vertical line test. So right now, moving this vertical line, I hit 1 point and 1 point only. Still moving along, I hit 1 point and 1 point only. Moving along, hitting 1 point. Oh, but what happened here? I hit 2 points at the same time. So this is what fails the vertical line test. And if you look at those points, it is 5, 2, and 5, 3. The same exact points here that are mapped out with different outputs. So this vertical line test has failed. Therefore, it is not a function, but we could see that from our set of ordered pairs as well. You can still list domain and range, but this relation is not a function. Let's look at another relation. The set of ordered pairs are 0, 2, 5, 4, 2, 2, and -4, -1. Now, this is still a relation. We have a set of ordered pairs. We can list these off in our table. 0, 2, 5, 4, 2, 2, and -4, -1. If you want to list these in order, you can, but I'm just basically writing them as a table format. Next, I'm going to put them into my mapping. I've got 0 mapping out to 2. I also have 2 mapping out to 2, so I can also put a 2 right here and map it out to 2. I've got 5 mapping out to 4, and I have -4 mapping out to -1. The last piece I'm going to do to show this relation is make it in a graph. 0 on the x, but +2y. 2, +2. +5, +4. And -4, -1. Now let's take a look at this relation. So far, you might be noticing some things. We have 0 mapped out to 2, 5 to 4, 2 mapped out to 2, and -4 mapped out to -1. Now, if you look at your inputs on your table and your mapping, we do not have an input mapped out to two different outputs. 0 is only mapped out to 2. It's not mapped out to another number. 2 is only mapped out to 2. It's not mapped to another number, as well as 5 and -4. And if you look at your vertical line test, passing through 1 point at a time, and it's not crossing 2 points at the same time. So you may ask, is this y value affecting whether it's a function or not? And it is not. So this is a function. You can have the same output to different inputs, and that considers a function still. As long as it passes a vertical line test, you don't have a mapping like 0 mapped out to two different numbers. The 2 can take on two different inputs, and that's still okay for a function. And same checking your table or your ordered pairs. You are checking to make sure your inputs are not mapped out to two different outputs. So 0, there's no other 0 input. 5, there's no other 5 input. 2, there's no other 2 input. And -4, there's no other -4 input. So that's what you're looking for on whether it is a function or not a function. The last thing we're going to do is list off domain and range in roster notation from least to greatest. So the domain for this one from least to greatest starts with -4, 0, 2, and 5. And next I'm going to list off my range from least to greatest. So starting with my y values, -1, 2, you do not have to repeat 2, and 4. All right, so hopefully you kind of getting a better understanding of what a relation is, what a function is, and how to write out roster notation. Let's flip to the back side. Directions say, for each relation below, so I've given you that each of these are relations. State whether it is a function or not, then identify the domain and range. Even if it's not a function, we can still list domain and range. So let's take a look at this first problem. We have our inputs, our outputs, which is the same as our x and our y. And we notice here that 7 to 6, 3 to 5, 5 to 4, 3 to 3, and 7 to 2. What do you think about this one? Well, if you're thinking, I've understood what a function is, and I see here 3 is mapped out to 5, and 3 is mapped out to 3. So this input of 3 is mapped out to two different numbers. So this one is in fact not a function. I can list the domain and range. I'm just going to put D for domain, R for range. As roster notation, my lowest input is 3, then 5, and then 7. Oh, look at that. I didn't even notice at first. 7 also knocks it out for not being a function. 7 to 2, and 7 to 6. So this is also making it not a function. My range or my outputs from least to greatest is 2, 3, 4, 5, and 6. All right, so let's look at the next one. Number 2 is a mapping. I have 2 mapped out to 4, 6 mapped out to 4, and 8 mapped out to -3. Is this a function or not a function? This one is a function. Let's talk about it. Even though 2 is mapped out to 4 and 6 is mapped out to 4, this is okay for a function. As long as 2, the input, is not mapped out to two different numbers. In this case, it is not. We are allowed to repeat our outputs, we just cannot repeat our inputs. So let's put our domain and our range. So starting our domain, our least map value is 2, then 6, and then 8. And then for our range, least value is -3, and then 4. All right, looking at number 3. We've got these 3 points here on a graph, and from our graph telling whether it's a function or not, that's when we use, and you can use a pencil, you can use anything, a vertical line, not horizontal, vertical line test. Looking at this vertical line test. So looking through here, it hits 1 point at a time and not hitting 2 spots at the same time. So this passes the vertical line test, which makes it a function. Listing off the domain and the range. Looking at my x values, you can go ahead and go through here. You can see this is 2, 4, and you can list off your ordered pairs, or you can go straight to the domain. But this x value starts on 2 as the smallest, and then 3, and then my last point has an x value of 5. My range or my y values, so I'm going to go to the very bottom where my y value starts, and this is 1. My next point has a y value of 3, and my last point has a y value of 4. Like I said, if you want to list off the ordered pairs to make it easier, like your inputs for your mapping or your table, you can do that. Or you can just search the graph, and I always go from left to right, and then from the lowest part up. The last one I want you to take a look at, maybe pause the video, and see if you can get whether it's a function or not a function, and list your domain and range. When you're ready, play the video. Okay, hopefully you had a chance to look at this problem. I highlighted 9, -3, and 9, 1 because those two ordered pairs in the relation make this not a function because 9 cannot map out to two different outputs. You can, however, continue to write the domain and range. So the domain is -7, -6, 3, and 9. And my range is -3, 0, 1, and 2.5. Always list them from least to greatest. All right, let's talk about some situations now. We're going to answer the following questions based on the situation. The relation represents an age of each student and the number of pets a student has. Is this a function? Explain. So hopefully you're already in this mode of function, not a function. This is given as a table. And I notice here that 11 is mapped out to 1 and 11 is mapped out to 2, which makes sense. There's no way you're going to find 11-year-olds who only have one pet, because in this classroom, I bet there's a lot of 14, 15, 13, 14, 15-year-olds who own one pet, who own 2 pets. This is not a good example of a function because there's so many people at the same age with different amounts of pets. So this is not a function, no. And I'm going to explain and say 11 maps to both 1 and 2 pets. Identify the independent and dependent variables. All right, so let's do something kind of new here. Let's go back to the front of notes. Your input variable is called the independent variable. Your output variable is called the dependent variable. So looking at this, your x and your y, these are your inputs, and these are your outputs. When it actually asks for the independent and dependent variables, I want to know in the context of the problem what they are. So our independent variable, or our inputs, are all of the ages of these students. The dependent variable, or the output of the problem, are the number of pets. The next thing we're going to do is identify the domain and range in roster notation. We've done this plenty of times. So I'm going to list off domain and range. Just don't forget to go from least to greatest. So for ages, the domain will be 6, 8, 9, and 11. You do not have to repeat 11. My range is 0, 1, 2, and 3. All right, moving on to number 2. This relation represents the times driven in hours and the number of miles traveled at the end of each hour. Is this a function? Well, I know from a graph that we can do the vertical line test. It does not hit 2 points at the same time from a vertical line. So yes, and the reason I found that was it passes the vertical line test. All right, so the next thing says, identify the independent and dependent variables. When it actually asks for the independent and dependent variables, we want to know in the context what our input and outputs are. So let's go ahead and do those. Our independents are the inputs or the x values. So this is our time, and we can actually specify in hours. Our dependent variable, or our y values, is given on the graph as our distance, and we can actually specify it as miles. The more specification you can give, the better. And last but not least, we're going to identify the domain and range in roster notation. So our domain, if you want to write the order pairs, you can, or you can just look at your graph. The first point starts on 1. So 1. The next point is on 2. The next point is on 3. The next point is on the x value 4. And the last point is on the x value 5. My range, or my y values, the first point is on the y value 50. The next point is on the y value 100. These 2 points are on the y value 150. You only have to list it once. And the last point is on the y value 200. Notice I'm not listing 250. 250 was on the graph, but I don't care about the graph. I care about the actual ordered pairs. No ordered pairs fell on 250, so it's not part of my range. All right, let's go to number 3. This relation represents the number of hours a person is able to rent a canoe and the cost of renting a canoe for that many hours. I want you to try pausing the video and working this one out. All right, the first question asked, is this a function? And yes, it is a function. My explanation, I said there is one input for every one output. I did not have 3 mapped out to 2 different numbers. All of these inputs mapped out to exactly 1 output. My independent variable were the hours, those independent variables, and the dependent was the cost, the outputs. Roster notation for my domain was 1, 2, 3, 4, 5, and the roster notation for the range was 11, 13, 15, 17. Remember, it is okay that 1 mapped out to 11 and 2 mapped out to 11. You just cannot repeat your inputs to your outputs. All right, our last one is given a situation, and we have to set up the mapping first. A person can burn about 6 calories per minute by bicycling. Let X represent the number of minutes, that's our inputs, and let Y represent the number of calories burned. Create a mapping diagram to show the number of calories burned by bicycling for 60, 120, 180, and 240 minutes. So those are the minutes I'm going to map out for. 60, 120, 180, and 240. So it tells me in the problem that you can burn about 6 calories per 1 minute bicycling. So I'm going to take my calculator, and if I'm bicycling for 60 minutes, that means I'm burning 360 calories. And there's the beginning of my mapping. Do the same with 120, 180, and 240. All right, now that we've created our mapping, we can go ahead and answer these questions. If you want to pause the video, you can, or you can work with me. This one asks, is it a function? Explain. I'm going to put yes, because every one of my inputs has exactly 1 output. So 1 inputs has exactly 1 outputs. The independent and dependent variables the independent was what we inputted, and we actually came with our inputs multiplying to 6 to get our outputs. So our input is we inputted the minutes, and our output was the number of calories burned. I'm going to put calories burned. The last part here is identifying the domain and range in roster notation. If you haven't noticed already, your independent variables always match up with your domain, because those are your inputs, and your dependent variables always match your range or your outputs. So my domain will be all of the minutes from least to greatest. And my range, same thing, will be my calories though, from least to greatest. All right, you do have a class worksheet as well as homework. I will allow you to work in partners on your class worksheet if you can keep your talking to a minimum. As soon as you're finished with classwork, you can go ahead and check your answers on Canvas and then start working on your homework. All right, enjoy!